In 1966, one fascinating word was presented in a paper in Europe, changing the study of friction and engineering. 1966. What a wonderful year. It was the year of the ATM patent, the first year of Medicaid, the year I was born. The Beatles' album Rubber Soul was #1 for 6 weeks. NASA's Luna 9 became the first spacecraft to land on the moon. Muhammad Ali refused to be drafted into the Vietnam War and was sentenced to prison and banned from boxing for 3 years. And it was the year of the very first episode of Star Trek. Also, it was the year of tribology. What is tribology? Well, tribology is the science of interacting surfaces, which studies the wearing down, the lubrication, and the friction of those surfaces. The study of friction would be impossible without the study of tribology. The history of math is our intellectual foundation for understanding science. Science. Beautiful, remarkable, awe-inspiring science. It's the creative foundation for our ineffable future. Hi, I'm Gabrielle Burchak, and this is my podcast, Math, Science, History. In the year 415, the infamous philosopher and mathematician Hypatia of Alexandria, Egypt, was savagely murdered by church monks. This murder shocked the Roman community and its government leaders. Hypatia was known far and wide as a respected philosopher, mathematician, government advisor, and a professor. Hypatia, The Sum of Her Life, is a book that I wrote that looks not just at the circumstances surrounding her death, but also at the sum of her entire life. I weave in the details of her education, disciples, Neoplatonic philosophies, female contemporaries, and the many mathematics that she wrote and taught about. There is truly more to Hypatia's life than her death. Hypatia, The Sum of Her Life, written by me, Gabrielle Burchak, is now on sale on Amazon. Buy your copy today. I have always been fascinated by the stories of people convinced that aliens built the pyramids. It's as if they don't want to give humans any credit for the incredible work that we have done throughout our existence. Those beautiful constructs would not be here without our brainpower to understand the value in reducing friction. The pyramids that fill us with awe and wonder were possible because ancient architects and engineers understood the concepts of tribology. All of those exterior limestone blocks and interior granite for the inner chambers were quarried nearby and were moved through the process of dragging them over wet sand. In Latin, the term friction was frictionem, which means to rub down, or scrape two things together. The long and rich study of friction brings together many astute philosophers and scientists, including Aristotle, Vitruvius, Da Vinci, Coulomb, Amonton, Leslie, and Reynolds. Aristotle flourished around the 4th century BCE. He indirectly addressed the concept of friction, motion, and resistance in his 2 works, Physics and Mechanics. Vitruvius, the Roman architect and engineer from the 1st century BCE, referenced friction in his work on architecture. Pliny the Elder, from the 1st century CE, 200 years after Vitruvius, he described the frictional properties of materials used for tools and machines. Pliny also mentioned how lubricants and materials, including oils and grease, could reduce friction in mechanical operations. This was one of the very first references to the foundations of tribology. And then some of our earliest writings that address friction come from Leonardo da Vinci from the 15th century Renaissance era. Many of his writings and observations can be found in his codices, which include Codex Arundel, Codex Atlanticus, and his 2 notebooks found in Codex Madrid I and Madrid II. As the observant, ingenious individual that he studied and noted the difference between sliding and rolling friction. In the 17th century, during the Enlightenment, the French physicist and engineer Guillaume Amonton, inspired by Da Vinci, expanded on his work through the studies of friction and thermodynamics. Amonton's work was profound in that he verbally formalized Da Vinci's first laws of friction and then built on it with his 3 laws of friction, which I will go into in my next podcast, so stay tuned for that one. In the 18th century, the French officer, engineer, and physicist Charles-Augustin de Coulomb expanded on Amonton's laws. Coulomb influenced our present-day understanding of friction that was foundational for the study of tribology. Coulomb was a French engineer, officer, and physicist. In 1779, he published his analysis of the laws of friction, which in English is titled Theory of Simple Machines, having regard to the friction of their parts and the stiffness of the ropes. 20 years later, he published a memoir on his research in fluid resistance. These works provided an even greater understanding of fluid flow and how it relates to tribology. Furthermore, Coulomb established his primary theory on friction, which we now know as Coulomb's law of friction, which explains how the force that resists the movement of 2 surfaces sliding against each other depends on the weight of the object and the roughness of the surfaces. In other words, the harder the surfaces are pressed together and the rougher they are, the more friction there will be. His findings are still used in engineering and physics, particularly in designing machinery structures and understanding natural phenomena. He significantly influenced theoretical and applied mechanics and laid the groundwork for further tribological developments. So, by the time the 19th and 20th centuries came about, the Industrial Revolution was in full swing. The study of friction underwent significant changes during the Industrial Revolution, driven by the increasing demand for efficient machinery and the need to understand and optimize mechanical systems. As a result, understanding friction was necessary to improve the efficiency and durability of these machines. Engineers focused on reducing friction to improve the performance of moving parts like gears, bearings, and wheels. This then led to the development of better lubricants and the study of wear and tear. Additionally, advancements in lubrication led to longer-lasting and more efficient machines. This then led to the study of fluid friction. John Leslie studied the effects of temperature on materials and how heat influences friction. Leslie was a Scottish mathematician and physicist who contributed greatly to the research of heat and temperature. He investigated how heating and cooling materials affected their frictional properties and contributed to a deeper understanding of the relationship between thermal conditions and mechanical behavior. It was groundbreaking. Additionally, he found that managing heat and friction was critical to maintaining proficiency and preventing damage to the components of many of these advanced machines. Osborne Reynolds, a British engineer and physicist known for his pioneering work in fluid mechanics, also contributed significantly to the study of tribology. And for myself, having studied Navier-Stokes equations and fluid flow, I personally think that Reynolds was one of the most brilliant physicists who laid some significant foundations for fluid dynamics. He's best known for introducing the concept of the Reynolds number, which, get this, is a dimensionless quantity that predicts the flow in fluid dynamics. That is just so mind-blowing. And he also developed the Reynolds equation, which describes the pressure distribution in a thin lubricant film between 2 surfaces. And even though his studies focused on fluid flow, it had direct implications on friction, the study of lubricants, and the design of bearings. Because of Reynolds, there became a greater understanding of the effective design and application of lubricants utilized in industrial machinery. The contributions of Leslie and Reynolds, along with other scientists and engineers, helped advance the concepts of tribology, leading to significant improvements in the design and efficiency of industrial machinery. These advancements were essential for the continued progress of the Industrial Revolution, enabling more reliable and efficient machines that could operate at higher speeds and under greater loads. So, the study of friction paved the way for modern tribology and its applications in various industries. The term tribology comes from the Greek word tribos, which means rubbing, and was coined in the mid-20th century to describe this multidisciplinary field that plays a crucial role in engineering and material science. As I noted earlier, the primary components of tribology include friction, wear, and lubrication. Friction, one of the fundamental aspects of tribology, can be beneficial because it can provide grip, and detrimental because it can destroy the surface and cause energy loss. Wear is the gradual removal or deformation of material from a surface due to its constant mechanical action, which includes sliding, rolling, or impacting. This wear can lead to the degradation of machine components, which reduces the lifespan of the machinery. Finally, lubrication can include oils, greases, and even gases that operate like a thin film separating the surfaces and reducing direct contact. The term tribology was coined by the prominent British physicist and mechanical engineer Peter Jost in a landmark report published in 1966 titled Lubrication, Tribology, a report on the present position and industry's needs. Jost was a key figure in raising awareness about the economic impact of friction, wear, and lubrication in industry. He apprenticed at the Associated Metalworks in Glasgow and then went to Napier & Sons in Liverpool. In Liverpool, he won the Sir John Larking Medal for a paper on measurement of surface finish. By the time he was 29, he was working at Trier Brothers as a general manager and worked his way up to become director. With every position he took, he contributed to the development of tribology. At Trier Brothers, he sought to prevent the scaling of boiler tubes, so he created a sophisticated method of lubricating steam machinery. He eventually went on to serve as a director and chairman of many engineering companies in Britain. He had a rich career with many awards. He was honored by the heads of state in Austria, France, Germany, Poland, and Japan. In 1992, he was the first honorary foreign member of the Russian Academy of Engineering. He was bestowed 2 honorary professorships and 11 honorary doctorates, one of which included the first Millennium Honorary Science Doctorate. He was a fellow at the Institution of Engineering and Technology, the Institution of Mechanical Engineers, and the Institute of Materials. And that is just a few of his honors and decorations. Sadly, he passed away in 2016. Even so, he still receives posthumous awards for his extensive work in engineering and tribology. His report, known as the Jost Report, emphasized the need for systematic study and application of tribology to reduce costs associated with machinery wear and energy loss. The term tribology was officially adopted to describe this multidisciplinary field that encompasses the study of friction, wear, and lubrication, marking the beginning of tribology as a recognized scientific discipline. This report was necessary for the importance of this study for use in industrial applications like the design and maintenance of machinery and equipment, energy efficiency, and material science. This was also necessary for studying the properties of materials such as hardness, roughness, and chemical compositions. Furthermore, this report aided in reducing the environmental impact that comes from replacing worn parts and reducing the ecological footprint of oils and greases. Finally, the report highlighted that the lack of proper understanding and management of friction lead to significant financial losses in various industries. Jost's report highlighted the economic importance of systematic research and education in the field of tribology. He emphasized the need for more focused research and development in tribology. He identified gaps in existing knowledge and research. He called for education and training in tribology for engineers and scientists. He showed how the cost of education would save costs for the industrial industries and increase efficiency. He also called for the adoption of better practices in lubrication, material selection, and machine design. Finally, he called for collaboration among different fields, including physics, chemistry, material science, and engineering, to further understand and apply tribological principles. The Jost Report increased the recognition of its importance and spurred on significant advancements in research, education, and industry practices. It helped establish tribology as a distinct scientific and engineering discipline. With the burgeoning industry in aerospace and aviation in the 1960s, the study and application of tribology became necessary. These developments reduced friction and wear in aircraft engines, leading to greater fuel efficiency, higher power output, and extended component lifespans. By understanding the mechanisms of friction and wear, engineers were able to create engines with lower frictional losses and design components that could better withstand the extreme conditions of high-speed and high-altitude flight. This contributed to the overall reliability of aircraft and reduced the risk of mechanical failures, which was crucial for both commercial and military aviation. Tribology also played a key role in enhancing safety and innovation within the industry. The insights gained from tribological research enabled the development of predictive maintenance practices, allowing for components to be serviced or replaced before failure, thus improving aircraft safety. Additionally, the study of tribology facilitated the use of lighter materials without compromising strength, leading to weight reductions that improved fuel efficiency and performance. These advancements in material efficiency, combined with innovative designs informed by tribological principles, helped drive the technological progress of the aerospace and aviation industries during this pivotal era. Today, in nanotechnology and micro-electromechanical systems, tribology provides essential insights into managing friction, wear, and lubrication at microscopic scales. The ongoing research in tribology continues to drive innovations in both areas, addressing the unique challenges posed by the nanoscale and micrometer scale environments. It's fascinating to see where we will go with the study of tribology. In nanotechnology, traditional lubricants may not work effectively at the nanoscale. Tribologists investigate alternative lubrication methods, such as molecular scale lubricants or self-lubricating materials to reduce friction and wear in nanodevices. Integrating tribology with atomic force microscopy has enabled nano and microtribology research, which focuses on the study of friction and wear at the nanometer scale. This research contributes to the development of new materials and coatings with improved tribological properties. Additionally, research into innovative and adaptive lubricants that respond to changing conditions like temperature and pressure continue to evolve even at the nano and micro scale. And this has led to the development of nanofluids, which are suspensions of nanoparticles in conventional lubricants. And now, with artificial intelligence, machine learning, and quantum computing, we can make further advancements in nano and microtribology, computational modeling, and simulation. But wait, there's more. So, developments in green tribology focus on developing eco-friendly lubricants and materials that minimize environmental impact. This includes biodegradable lubricants and materials that can reduce energy consumption and waste. Currently, tribological research supports advancements in renewable energy technologies, including wind turbines and hydroelectric systems. Tribology also plays a role in developing medical implants, prosthetics, and diagnostic tools. The study of tribology has expanded into areas unimaginable. From the Industrial Revolution to spaceflight to healthcare, this study and all its applications are changing how we operate. As we look to the future, we envision a world where tribological research drives the development of smarter, more efficient, and environmentally friendly technologies for transforming healthcare. Imagine tribology enhancing the performance of medical implants, prosthetics, and diagnostic tools, making them more dependable and effective. The quest for reduced friction, minimized wear, and optimal lubrication promises to revolutionize our everyday devices and improve patient outcomes. The field of tribology, though often behind the scenes, is pivotal to advancing technology and industry. From its roots in ancient mechanical studies to its innovative applications in nanotechnology and sustainable innovations, tribology continues to evolve and inspire. By embracing the challenges and opportunities ahead, we can harness the power of tribology to create a future where technological progress aligns seamlessly with our pursuit of mechanical sustainability, technological innovation, and advanced healthcare. When it aligns, and when it performs powerfully together, it's like that impeccable operation of tribology, where the friction becomes minimal and our advancements become unstoppable. Thank you for listening to Math, Science, History. And until next time, carpe diem. Thank you for joining me at Math, Science, History. Please remember to subscribe to the show. Also, if you could please leave a rating or a review, it would be really appreciated. Because those ratings and reviews really do help to increase my listenership, which help to get me more sponsors, which help me keep the podcast up and running. If you want to learn more about the history of math and science, please visit me at mathsciencehistory.com. If you like what you're listening to, and if you like what you're reading, please feel free to click on that coffee button and buy me a cup of coffee. Every cup of coffee that you buy helps me pay for the expenses that go into making this podcast. Also, if you're interested in leaving me a comment or chatting with me, you can always find me on your preferred social media platform, including X, Instagram, Facebook, LinkedIn, Goodreads, TikTok, Threads, etc., etc., etc. Just go to Google and search for Gabrielle Burchak. You can find me everywhere. Until next time, carpe diem.